Today we're going to talk about logarithms. So it's a really basic introduction and it's lesson 1. So before we talk about a log symbol and stuff like that, we're going to first talk about functions. So how do functions work? Well, I have a function here, f of x. Now I input x, right? I input x, and then I get an output y. Now about inverse functions. F of -1 x, right? So the inverse function of x, you input y and you get x. That's like a cycle here. So you can imagine for f of x, you're looking at the function from the input. So f of x is actually just asking, where will I go with this input x, right? So where will I go with this input x? Like, will I go to y or will I not? What's my output? Now, the inverse function of x is going to ask, where did my y come from, right? Which x did my y come from? So these two are actually completely opposites, as you can see. This is asking, where did my y come from? And this is asking, where will I go with this x? So, logarithms are essentially the inverse function. Logarithms are inverse functions of exponential functions. So if you input x into an exponential function, let's say the exponential function is 2 to the power of x, then you can imagine that this actually means, I have a tool, so I have a machine, and I start with an object of size 1, and then every minute I increase the size by 2, so I multiply 2 to the size, I double the size. So every single minute I double the size. And the total amount of minutes is x. So the input is minutes, the time. The input is the time. I input the time and decides the amount of minutes that I double my original object of size 1. So I get my output. Right? So I get my output. Now logarithms is essentially I get this enlarged object. So the final size, right? I get this enlarged object and I plug it into my logarithm and I get the time. So the starting size is always 1, but if I plug it into my logarithm function, so this is the base and my result is the input, then essentially I get the time. So essentially I get the time. Or you can say that the input is the output of f of x. So like that, and then essentially if I do this, I go like, so I know that every minute I double it by 2. That's the base here. And I know that I've doubled my size for y minutes. I doubled my size such that it has a final size of y. How much minutes did I double my size for? That's x. Okay, so so log is just the inverse of 2 to the power of x. So I hope you understand that bit. So now we've understood that, let's look at a few examples to actually, master this thing. So the first example 1, is going to be, example 1, let's just say, I have 2 to the power of 3. What is that? Well, that's obviously 8. But really, what does this mean? It essentially means when I input 2, and so my input is 1, right? My input is 1, and then every minute, so my starting size is 1. And then every minute, I double the size, which is why the 2 is here. If it's 3, then every minute I triple the size. But every minute I double the size, and I double it for 3 minutes. This is actually the x. I double it for 3 minutes. So this is 2 to the power of 3 this is actually f of x equals 2 to the power of x when x is 3, right? So I double this object of 1 for 3 minutes, so my final size is 8. Now if I try to double my object, so let's just try another example a bit more complicated. So I'm gonna try 2 to the power of 4 times 2 to the power of 2. That obviously gives me 16 times 4, which is 64. Or you can say 2 to the power of 6, right? Which is 64. Now, how does this actually work though? It essentially means, firstly, I start with an object of 1. So I start with 1. I double the object's size every minute for 4 minutes straight. Now, my final size is going to be 16, right? If I do this, that's just really simple, like the one above, where x is 4, so that's 16. Now I start with 16 as my original size. So I start with 16 as my original size, and for every minute, I double my 16 by 2 for 2 minutes straight. So it goes from 16, I double it after 1 minute to 32, I double it after another minute to be 64. So that's just 64. And this is actually the same as I start with this object of size 1 and I double it for 6 minutes straight. Right? So that's the same as, so this is the same as this. So essentially that's just about logarithms. So for logarithms, if I give you log to 8, this should be 3. It's asking, how many minutes did I double 2? How many minutes did I double 1 such that it got to 8? Well, the answer is 3, because you go from 1 to 2, that's 1 minute. You go from 2 to 4, that's 2 minutes. You go from 4 to 8, that's 3 minutes. So you take 3 minutes to double from 2, so you double 1 until it gets 8. Now what about log 2 16 plus log 2 4? Log 2 4. Now you can calculate this easily. This is just 4 plus 2, which is 6. But this works also another way. You can combine these and get log 2 64. So you have 16 times 4. That's 6. So why is that? Because this one you're asking, how many minutes did it take to when I started from 1 and I doubled it the size of 1 every minute such that it gets to 16. The second expression is asking, I start from 1 and how much minutes do I have to double so that I get to 4. Now if you combine these, it's actually just, if you decide that I have 16, right? And if you decide that, so this essentially just means that how much minutes I have to double 1 such that it gets to 64. Now, that's the same thing as making it for 16. Then if you double 16 2 times such that it's 16 times 4, then you get 64, right? So that's the same thing as this. So let's just try another log where the base is not 2. So log 5125. That's 3 because it's asking, I start with 1. Every minute I times 5 per minute, and then I get 125. How much minutes do I have? So how much minutes did it take to do this? Well, it took 3 minutes. Firstly, 1 to 5, then 5 to 25, then 25 to 125, right? So there we go. So thanks for watching.